Hey, good morning, everybody. So today we are going to move on to the next lesson. It's actually going to be really, really simple and really, really easy, and something we've done like 3 times before, finding solutions by graphing. So I think the lesson itself will be extremely short, and probably the warm-up will take longer than the lesson itself. So you have a lot of work time to work today. The homework over this, though, since it will be so simple, will be due tomorrow. So mental note on that, homework will be due tomorrow. All right, let's dive in and do some Pascal's triangle and binomial expansion theorems and all that kind of jazz. Here we go. Number one today is asking you to expand negative 3x minus 4. They're both negative, so the negative 3x is negative and the negative 4 is negative as well. And that's raised to the third power. So again, when you're looking at this, make sure you see two distinct terms. I see a term here is negative 3x. I also see another distinct term, negative 4. And you've got to include the signs, right? So if they're positive, great. You don't have to write plus, it's stupid. But if they're negative, definitely put some minus signs. And what you always do is you go to the triangle first off the bat, and you look at the power. You know, this is the third power, so you go find the one with the 3 in it, and that row with the 3 in it is 1, 3, 3, 1, as you see on the board. So here we go. We go down the line. We go through those coefficients. 1 times, and then one of the quantities is raised to the biggest exponent, and the other quantity is raised to the smallest exponent. So the third power is the biggest it's going to get, and the lowest power you're going to get 0. Once you got that down, then you just go down the line of the things in this triangle. So the next thing in the triangle was a 3. So you write plus 3. You keep adding up every single term. And the next term, well, the negative 3x term, if it started high, it's going to go down. So it's going to be raised to a second power now. And if the negative 4 started low, it's going to go up and be a first power now. And you just keep on doing this as you go down the line. The next number on the row is another 3. And that's times the negative 3x to the first, and the negative 4 to the second. And then the very last thing on the row is the 1. And that has the negative 3x now raised to the nothing power, and the negative 4 is raised to the third. So that's the pattern of all this stuff, what you've been doing on your homework. And then probably the harder part is actually cleaning it up. You know, as usually what we're struggling with is, exponents and things like that. Well, here we go. Let's see. First thing to spot is anything to the 0 power doesn't really matter, right? Anything to the 0 is 1. So that's a 1, and that's a 1. Really, it's just this thing here. Now, I do see a number in here. There's a negative 3, and it's cubed. So you need to figure out what negative 3 cubed is. Anybody know what negative 3? Negative 27, yeah. So this is negative 27, and there's a variable, too. There was an x, and it was cubed, so negative 27 x cubed, the first one. And you just keep cleaning as you go. So this one over here, let's see. I always like to look at the signs first. This is a negative raised to the first. It's just a negative then, right? Negative times, what's this? If you square a negative, what do you get? Anybody know? A positive, right. So this is a negative, and this is a positive, and that's a positive. And so a negative times a positive is a negative, and a negative times another positive is a negative. Remember how you slice it, it's going to be a negative. And that's too convoluted for you. Just type this in your calculator, right, without the variables. We're going to have to do that anyway. Let's figure out what the numbers are. So let me figure out what 3 times 3 squared times 4 is. You probably do it in your head, too, if you're thinking about it. You might want to do it on your calculator. I'll try to do it in my mind. 3 squared is 9, right? And 9 times, 4 is 36. And 36 times this 3 in the front is what, 108? Is that what you got? 108. So this thing's minus 108. And the x was squared. Okay. All right, next one. Let's see about this guy right here. You got a negative and a squared. A negative squared is a positive, right? So that's a positive. This is a negative. Positive times a negative is a negative. So this one's going to, well, is it? Am I off somewhere? Oh, no, I'm not. Oh, it's another negative. Yeah. I thought I should oscillate. Usually they go plus, minus, right? Not always. Sometimes I just go minuses all the way through and all that crap. This one, let's see. 4 squared is 16. There's another 3 and a 3. 3 times 3 is 9. 9 times 16. Anybody got that? I don't got that. Was it? That sounds about right. I believe that. 144. And then, of course, the x was raised to the first, so you just write x. And the very last one, something to the 0, so you don't even worry about it. There's a 1. Don't worry about it. Negative 4 cubed. If you type that in your calculator carefully, it's negative 64. So there's a whole bunch of negatives in this one. And you could probably expect that all the time if both of them are negative. If both are positive, they're all going to be positive. If both are negative, they're all going to be negative. And if one's positive, one's negative, have you seen what happens in the pattern? It goes usually plus, minus, or something like that. So that's something to know what's going to be expected as we go down the pike. All right, number 2, same idea basically. 2z is the quantity minus 4w. And it's just squared, so that won't take very long. If I was actually going to do this in practice, I would just write times itself and distribute it out, but we're practicing the binomial theorem, so we'll do it the long way. 1, 2, 1 would be this row, correct? The one that starts with the 2. So here we go, 1 times, and the first quantity is a 2z, so maybe we'll have that one start high at the second power. The other quantity is a negative 4w, so negative 4w will start off being raised to the 0. And going down the line, it's just 1, 2, 1 is the pattern in this triangle, so the next number is a 2. We did the 1, we did the 2, now it's got 2z raised to the first. That went down an exponent, the negative 4w went up an exponent to be a 1. And then you got yourself another 1 on the end of your pattern, and finally the 2z is raised to the 0, and then negative 4w is squared. Note the parentheses. Parentheses are very, very important. All right, let's clean it up. This one's to the 0, doesn't matter. This one's a 1, doesn't matter. Well, really, it's just 2z squared. 2 squared is 4, and z squared is z squared, so this thing is just 4z squared. Going to that middle term now. Let's see signs first. As predicted, one's positive, one's negative, right? So it will oscillate. This will be positive. The next one will be negative. To confirm that real quick, here's a negative raised to an odd power, still negative. Those are positives, so negative times a positive is in fact a negative. As far as numbers go, everything's to the first power, so there's no exponents to really do. Just 2 times 2 times 4. 2 times 2 is 4. 4 times 4 is 16. And the letters still chilling around. You got a Z and a W. It doesn't really matter what order you write them in, but we'll do that. And then the very last one, something to the 0 doesn't matter. It's 1. That's 1. So basically just this thing squared. Negative 4 squared is positive 16, correct? And 16, and you also have the W, it's just squared, so 16W squared. And as predicted, it oscillates from plus, minus, plus. Cool, cool. All right, let's keep going. Number 3. It looks scary because it's raised to the 7th power. But actually, you could probably get the answer for number 3 right off the bat. Number 3 just says x minus y to the 7th power. There's no numbers in front of these, are there? There's just x's and y's. That's kind of nice. And one's positive, one's negative. What do you know what's going to happen with the signs then? It's going to flip-flop back and forth. So essentially what this is going to look like is, this is 7th power, right? So you look at your 7th row, and what do you got? 1, 7, 21, all that stuff, right? So it's going to be 1 times x to the 7th. And I'm not going to write y to the 0 anymore, because I know the pattern is going to go what? It's going to be plus, then it's going to be minus, right? And the next one's going to be what? A 7 x to the 6th y. Do you see I'm cutting out the middleman right here? Kind of cutting it out. I'm just going right for it. You know, I don't even need the 1, do I? The 1 doesn't really do anything either. But I know it's going to be all x's and no y's, correct? Then the x's are going to go down, the y's are going to go up. And I'm going to have it go plus, minus, because I know what the pattern's going to be. So then after that's going to be a plus 21 x to the 5th y squared. And then after that, keep going down the line, plus 35 x to the 4th y cubed. Then there's another 35, so have the x's exponents go down, the y's go up. And what else we got on that? 21 x squared y to the 5th. And after the 21 comes another 7 and then a 1. So a 7xy to the 6th. And then a 1. And then there's no x's anymore, and it's all y's to the 7th. And I pretty much did the whole problem without, simplifying. The only thing really that's stupid in my work is I wrote the 1s. Really no reason to write 1 times something. So there's the final answer. I didn't even have to go simplify anything. I just knew from a plus and a minus it's going to oscillate. There were no weird numbers involved, so it's just going to be 1, 7, the pattern of the thing. And we're done. That's it for number 3. So that wasn't terrible. And then last but not least, number 4. Got to do something with fractions. Got to punish you a little bit. Number 4 says 1/2 x. And then it's minus 1/3 y. And unfortunately, that's raised to the 4th power. So we're going to have a lot of cleaning on this one. This one's just going to be a hassle because we hate fractions. Well, it's raised to the 4th power, so you go find the row with the 4s, and it's 1, 4, 6, 4, 1 there. So you dive right in. 1 times One of the things is 1/2 x, and the other thing is negative 1/3 y. So we'll have 1/2 x may be raised to the big power, and the negative 1/3 y raised to the little power. So there'd be the first term. After that, you look on your row, and after the 1 comes a 4. So we're going to write 4. And then the 1/2 x is now raised to 1 less power. And the 1/3 y, negative 1/3 y is raised to the first power. And you just keep on writing, right? You know what I'm going to write next. You can work ahead if you like. It's going to be a 6. After that, in your pattern comes another 4. And of course, your pattern always ends up with a 1 on the end. Boom, there we go. Whole thing's expanded out by my little patterns. A lot of cleaning to do. A lot of fraction work to clean this thing up, but that's okay. We'll get there. Oh, let's see here. This is to the 0, correct? Don't need it. Don't worry about that. This is a 1. Don't worry about that. 1/2 to the 4th. Now, if you have a fraction raised to a power, you can do the exponent on top and bottom separately. What's 1 to the 4th power? It's just 1, right? Anybody know what 2 to the 4th power is? 2 times 2 times 2 times 2. Type in your calculator if you don't know. What's 2 to the 4th power? 16. But that was on the bottom, right? 2 was on the bottom. So when you raise it to the 4th power, it's going to be a 16th. That is the correct value of 1/2 to the 4th. And you had an x to the 4th. And the y was raised to the 0, so you don't really care about that. Then let's see about the next one. What sign's going to be next? Can you predict? What sign? Positive or negative? It's going to be negative because this is positive, this is negative, right? So it's going to switch back. That was positive already, so this one's going to be a negative. Let's look at some numbers. Well, let's start with this thing. It's a cube. That's scary. 1/2 cubed. What's 2 cubed? 2 times 2 times 2. Anybody know that? 2 times 2 times 2. Type in your calculator if you can't do 2 times 2 times 2. It is 8, yeah. So this is 1/8, okay? Now I have an 1/8 times a 3rd. How do you multiply fractions? Straight across. Can you see it in your mind? 1/8 times 1/3. What the 1 times the 1 is? It's 1, right? What's the 8 times the 3? It's 24. So this is 1/24. 1/24 times 4 is 4/24. Can you reduce 4/24? I think you can to 1/6. So that all turns into 1/6. And you got an x cubed on that one and just a y to the 1st. So we're kind of cool on that. Oh, next dude to clean 6. Well, here we go with squaring things again. First off, it's going to be positive. Do you buy that? Plus, minus, plus, minus. Plus, also, this negative is squared, and a negative squared is positive. So everything's saying it's positive. 1/3 squared is 1/9. Do you buy that? This is 1/9. This squared is 1/4. You buying that? A 9th times a 4th is a 36th. So this is 6/36, which reduces to, well, I don't know. What does it? Oh, I'm so stupid. What does 6/36 reduce to? 1/6. Okay, so this is going to be a 1/6. And this is going to have an x squared and a y squared on it. I can't believe I just had trouble reducing 6/36. And then we're on to this term right here. So here we go again. Oh, Lord. First off, it's going to be a negative, right? Should follow the pattern. Plus a negative to an odd power is a negative. So everything says the same thing. 1/3 cubed. Oh, Lord. 3 times itself 3 times. 3 times 3 times 3 is 27. This is 1/27. This is a half. 1/27. This is getting too much to do orally. 1/27 times 1/2 is 1/54 if you multiply straight across. And that times 4 would be 4/54, which reduces to 2/27, because 2 goes into both of those numbers that many times. And the thing that's left is an x to the 1st, or just an x, and a y cubed. So now we got that term taken care of. And then lastly, this one down here, we had a 1, something to the 0, doesn't really freaking matter. All we got is this thing. It's a negative raised to an even power. That would always be that's a positive, as it should be, is to follow our pattern. And I got to figure out what 1/3 to the 4th is, which basically means there's going to be a 3 to the 4th on the bottom. And 3 to the 4th, if you get your calculator out, type it in, is 81. So this turns out to be 1/8. 81st. So a gross answer on that one. A bunch of fractions, but that's what happens when fractions come up. You got to deal with fractions. Okay, like I said, that was probably going to take longer than the whole lesson will. Today's learning goal, here you go. We are moving on to the next unit, Unit 5. Unit 4 has kind of half of what I want you to know about polynomials in it. Unit 5 will have the other half. So like I said yesterday, when the test does come, which won't be for a couple weeks at least, it'll be over both these chapters, Chapter 4 and Chapter 5. Today's easy. You're just solving by graphing. Every time I say to solve something by graphing, we've done that a lot. I've had like 3 lessons over it, I think, already. Whenever you solve by graphing, you set it equal to 0, and you see where it crosses the axis. That whole sentence was essentially your lesson today. So we'll do a couple quick examples, and then we'll let you work, because it is that easy today. Very, very easy. All right, you got your homework due, of course. So homework 4.5 is due. Write down the new one. Here's the one due tomorrow, 5.1. Don't forget it's due tomorrow. You don't have 2 days on this thing. It's just too easy. Got to move things to one side and put in your calculator and see where it crosses the axis. That's the whole darn thing. There's a lot of things buried in this next unit that I don't think you're going to need, so I'm going to trim some of it just because, for time's sake, we got bigger things to learn. But there are some crucial things in this unit as well, so we'll cover everything at once. Notes, notes, notes. By the way, since this is a new unit, here's your title for the new unit. It's called Unit 5, Polynomial Equations. So this unit will much more focus on how to solve things with polynomials. So far, we talked about, okay, what do their graphs look like? And can you expand them out? Can you combine like terms? Can you do things with polynomials and multiply them and add them and divide them and all that long division stuff? And all those skills will come up in this next unit where we're learning how to solve things, but not day 1. Day 1 is going to be darn easy. Section 5.1 is titled Solving Polynomial Equations by Graphing. Very, very easy. Here's your notes. What should you probably write down? I would write down what? Set it equal to 0. Graph it and see where it crosses the axis. That's it. If you're ever on an ACT or you're ever stumped or you just don't know anything about math, you can always get an answer. It's not the best answer, but maybe a decimal answer for anything by just setting it equal to 0 and graphing it. So this one down here, they got an example. They got x squared plus 2x squared minus 4x equals x plus 6. Now, that's not equal to 0, right? So you probably subtract the x over, subtract the 6 over, and get this thing equal to the magic number of 0. Once you do, if you graph it, all you're doing is looking for where it crosses the axis, correct? So if it crosses at these 3 places, -3, -1, and 2, you say that your answers are x equals -3, x equals -1, and x equals 2. That's really all that there is to this. And let's just do a couple examples, then I'll turn you loose. Here's example 1. Copy it down in its original format. X to the 4th plus 3x squared minus 5 equals -4x cubed. The only thing you got to remember to solve by graphing is to set it equal to 0. So what's the first thing you guys would do? I'd probably just take this -4x cubed and add it to both sides, wouldn't you? Do that in your work. Add 4x cubed to both sides. On the left, might want to write in the normal order, x to the 4th plus 4x cubed, try to write it in the standard form. Doesn't really matter. And then once you got the whole thing set up, you just go to your calculator. Very, very easy. Go to y equals. Type in what you have set equal to 0. So yours should now say x to the 4th plus 4x cubed, right? Of course, you still got the other stuff, 3x squared. Got a -5. So whatever you got set equal to 0, that's what you plug in your calculator. Never a bad idea to reset your window. Zoom 6. It'll just give you the standard window. That works 90% of the time, so that's a good bet to start. And you look at it, and it looks like this thing crosses at 2 spots. Number 1, does this look like a 4th degree? This was a 4th degree, right? 4th degrees, but open up on both ends, correct? So that makes sense. And I see it crosses at 2 spots, so you know what to do. How do you find where they are? Second calc, 0. I'll take the one on the right because I'm pretty close to it already. Left bound, right bound, go anywhere to the left of where it crosses the axis, anywhere to the right of where it crosses the axis. Yes, doesn't matter. And here's one answer. Take a minute, write it down. X equals 0.84-ish. You don't have to write out every decimal place. I would. As a student, I always did that. Like, it doesn't hurt. So I'd write as many as you can, but don't say 0.8. That's too much rounding. At least 2 or 3 decimal places. If you say 0.84, I'm cool with you. There's one over here too, so you got to go find that. Second calc. Anybody find that already? Anybody ahead of me? What is it? Negative 3.21. There you go. There's the other one. Write down x equals negative 3.21. I believe that. I'm already halfway there, though, so I'm going to check it, too. Well, definitely within that range. Yep. Agreed. So that's it, right? That's all you got to do. Write down your answers. Easiest lesson in the world. Here's a check real quick. We'll do a couple more checks, make sure we got the idea. Use a graphing calculator to solve this. Now, of course, this is not equal to 0, right? And there's 2 things on the left and 2 things on the right, so it really doesn't matter. You know, it's almost as equally difficult to move one to the other side. What side do you guys want to be 0? Do you want the left to be 0, or do you want the right to be 0? What do you feel like? Let's have the left be 0. Okay, so if we're going to make the left 0, then we got to subtract the 4x squared, right? And subtract this x. Now, I'm not going to do the work. I'm going to do it right here on my calculator because it's not that complicated. On this side, we had a 1/2 and an x to the 4th. What I'm going to do is subtract over the 4x squared, so it'll be a negative 4x squared on the right. I'm also going to subtract this positive x over and make it a minus x on this side. And what was already originally on the right side was a 1, so it's still a 1. And just look at it real quick. Does that make sense? Yeah, it's the exact same thing as it was originally, just with a negative 4x squared and minus x on it. And then once you got that, you know, go ahead and graph it, zoom 6 or whatever you want to do. And this one looks like it has 4 solutions. That might happen with a 4th degree. I see it crossing 1, 2, 3, 4 spots. So let's all break out into groups and do them one by one. Somebody take the left and the middle two, and I'll take the far right one. I'll finish it up for you. Anybody get that far left one yet? Negative 2.63, I'm hearing. Sounds plausible to me, but looks about where it crosses. Negative 2.63. There you go. Somebody get this first one kind of close to the origin. Looks like about, I don't know, negative 0.7 or something like that. I'm just guessing. Negative 0.66. All right, negative 0.66. Do write x equals. You know, when you're solving something, you're trying to solve for x, do write x equals. That's a good habit. Anybody got this one here? The one kind of to the right? 0.39. X equals 0.39. Very good, guys. And the one I got over here is x is about 2.90, 2.91 if you want to round. I'd give you credit for either answer on a test. Nothing complicated, right? Very easy day. And that's it. Okay, so I don't have any more examples. Do you have any questions? I don't think you got any questions, right? Set equal to 0 and graph it, see where the zeros are. And that's it. So touch up 4.5 because that's due. 5.1, again, due tomorrow. So you don't have all day to do it. There's not that many problems. But try to get that taken care of before you go home today and have no math to worry about for tomorrow.